Now, so we got from the Thomson's experiment the cathode rays, we got it. Now, we have to know the properties of the cathode rays. So now we will know the properties. So what we'll do is that, first of all, what we'll do is that we will place here two plates. Alright, two plates, mean two electrodes we are going to place it. One positively charged electrode here and one negatively charged electrode here. Alright, we will place two electrodes, one positively charged and negatively charged. This is a positively charged electrode and this is a negatively charged electrode. I will be taking it. So you can see very clearly that the charge is negative. Clear? You can see very clearly. Now what we saw, that the rays which was travelling from cathode to that of the anode. Now instead of travelling straight, the rays got bent. It got bent towards, that is, anode. The rays got bent in this way. The rays got bent. Now how do we come to know that the rays got bent? Are we able to see the rays? Light rays? No, nothing. Alright, what I said, a streak of light. Streak means a fraction of second you got a light. Alright, that is called a streak of light. So rays you never see, because the light rays which are coming from your, what you can say, this light which you are seeing. Are you able to see the rays? No, we are able to see the light only. We are not able to see the rays. So rays is not visible. Always remember this particular thing. Alright, then how do we know? We coated here with fluorescent substance. Here and here we coated with fluorescent substance. Which one? That is ZNS. Both the side we coated it. Over the electrodes we coated it. So we saw the fluorescent here. This part was glowing, not this part. That means what it proves? That the rays traveled from negative to positive. That means the rays consist of negatively charged particles. For that reason only, it got deflected towards the positive plate. Suppose the rays would, would have contained positively charged particles, it would have deflected towards this particular side. So this side would have glowed. But this side is not glowing. Which side is glowing? This side is glowing. The glowing only indicates that the rays consist of negatively charged particles. Alright, so hence what it was proved, that cathode rays consist of negatively charged particles, and it was named as electrons. But let me tell you, the name of electrons was not given by Thomson. Thomson discovered the cathode rays. Thomson showed us that cathode rays consist of negatively charged particles. Alright, understood or not? Because the rays got deflected towards the positive plate. How do we come to know? Because this part was glowing. This part I have coated with fluorescent substance. So this part was glowing, not this part. So that it proves only that it consists of negatively charged particles. The name electrons was given by Stoney, another scientist. He kept the name of the electrons. The name electrons was coined by Stoney. Alright, Stoney, another scientist. He gave the name electrons. Okay. So first properties you understood, that cathode rays consist of negatively charged particles, that is electrons. Okay. Now next is that if you place that is a mica foil, cut it in the same of a fan. Alright. I am cutting a mica foil. Mica is a very light substance, very light substance. We can say that mica is a very light substance. I will cut it in the shape of a fan. Alright, and I will make a hole here, and in that hole I will put a pointed nail. I will put it, and the mica foil I will put it, and I will put it in this. Put it in the path of the cathode rays. Alright, the cathode rays is coming. I will put it. Now, what I said, mica is very light. It is so light that if you touch with your finger, it is going to break. So hence, you are picking up the mica foil with the help of forceps, chimta. Alright, a special forceps is there. We are picking it up. We are cutting it in the shape of a fan, and we are putting it in the path of the cathode rays. Alright, clear? Now what you will find is that this foil is going to rotate. The mica foil is going to rotate. You will find. What does it prove? What does it prove? That why this foil is rotating? It proves that cathode rays consist of particles which possess energy. It consists of energetic particles which possess energy. Hence, what you find? The mica plate, it rotates. So there is an interconversion of energy.